And you can put all that information together. Now, I want you to figure out this radioactivity in kilobecquerels. So when we start our railroad track method, our unit conversions, it's best to start with where do we want to go? Well, we want to have an answer in kilobecquerels. So we'll put that in the numerator. And we'll circle that so that we never cross it out, because if you don't cross it out, that's the final answer you're going to get. But what do you know about kilobecquerels? Well, let's see. A kilo of anything is 1,000 of it. So 1 kilobecquerel is equal to 1,000 becquerels, correct? Right? But I don't want anything to do with becquerels. I want my answer to be in kilobecquerels. So I say, okay, well, what else do I know about becquerels? Well, 1 becquerel from up above is equal to 1 decay per second. All right? Well, I got my kilobecquerels, but I still got these decays per second. So I want those to go away. Well, what do I know about decays per second? And I know that my answer was in nanocuries, so I can go from decays per second through curies and say, well, there's 3.7 times 10 to the 10th decays per second in every 1 curie of radioactivity. And now my decays per second cross out. So now I got kilobecquerels and curies. I don't want curies, and I know I have nanocuries to figure out here. So let's turn these curies into nanocuries, since that would be a pretty simple thing to do. And you can write this one of two different ways. You can say 1 curie is 1 times 10 to the 9th nanocuries, or if you really memorize that 1 nano is 10 to the minus 9th, what you want to do is you want to write it as 1 times 10 to the minus 9th curies, since curies is the base unit, is equal to 1 nanocurie. And then you can say, well, here's nano on the bottom, here's 10 to the minus 9th on the top. See that nano is equal to 10 to the minus 9th. So most students are going to do it this way. Some people do it and put the positive number in the bottom. It doesn't matter which way you do it. Here's what you want to remember. Lots of little things go into a big thing. So if you sit here and go, well, nanos, pretty small, one of those little things, I really got to chop up the big thing of Curie into a lot of little small pieces, or it's going to be a very small part. So 10 to the minus 9th of anything is very, very small. And so, yeah, I got small and small here, okay? If you would have wrote it as 1 Curie on top, and 10 is equal to 1 times 10 to the positive 9th in the bottom, that still would have worked out, because 1 Curie is huge, and it would take lots of nanocuries to make that happen. I don't care which way you do it. Just think that big and little thing. I don't know how many students I've had over the last 5 years that will write it backwards and get their problem all messed up. And if they would just think for a second, which one's big, which one's small, it takes a lot of little things to go into a big thing. All right. So now our curies can cross out, and now we have nanocuries, and now we can use our information from the very beginning that the amount of radioactivity we had at the beginning was 1.67 nanocuries. You can cross out the nanocuries, and now all of a sudden, all you have left is the kilobecquerels. So we take 1 times 1, and really, that's what you do in these railroad tracks. You just multiply by everything on the top, and then you divide by the things on the bottom. So we take 1, and every time you get to a bar, that means times. These bars, basically, you can think about them as times, 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 times. Okay? So you get to a bar, you multiply by 1, and so you got 1 times 1 is still 1. Now, the first thing you really got to go with is 3.7 times 10 to the 10th. And now the next thing is multiply by 1, exponent of the minus 9th. Please don't forget to use your EXP or E key for your scientific notation. Multiply by 1.67. And then when you get over here, you start dividing by each one of the things you find at the bottom. So we divide by 1,000. And then you divide by 1. You can divide by 1, divide by 1, which doesn't really matter. And when this is all done, we have 0.0618. And I went, man, I forgot what my units are. Have that ever happened to you? I mean, honestly, I was just doing this problem, and I have totally forgotten what the question was, what the units were. Oh, but all I got to do is look through here and go, well, let's see, I crossed out that, crossed out there, crossed out there. Oh, kilobecquerels, there they are, right there. That's the units, and I can even go back to what did the teacher ask me and make sure. But look, isn't that beautiful? And I kid you not, that's just what happened to me. I didn't know what units to write down there. I've done so many of these problems, I totally forgot. But guess what? If I use the railroad track method, I can go back and, oh, look, it's obviously the answer is in kilobecquerels.